in this video, we're looking at defining the exact value of composite functions with inverse trigonometric functions. So I apologize, this might be a little bit long, but just know that if you do the sine of sine inverse of x, you get x, for x being between -1 and 1. For cosine of cosine inverse of x is x, for x being between -1 and 1. And tangent of tangent inverse of x is x, for x being between -infinity to infinity. Now I want to point out, though, that the result is going to be something in the domain from, this will be between negative pi over 2. Let me erase this. To pi over 2. And for cosine, it's going to be 0 to pi. So what I want to point out is that will produce an angle, and then it'll be sine of that angle. Okay. So this one will be negative pi over 2 to pi over 2. And someone's probably going to say, wait a second, you're right, these can be closed, not open intervals. Okay. Then sine inverse of sine is also going to be x, for x being between negative pi over 2 and pi over 2, inclusive of the endpoints. Cosine inverse of cosine of x is x, for x between 0 and pi. And tangent inverse of tangent of x is x, for x between negative pi over 2 and pi over 2, not inclusive. So what I really want to get the point out across, the value for this first set here, the reason I gave this notation here is that when you are getting the angle from the inverse function to plug into the regular function, the angle is going to be within the domains necessary to make the trig function a one-to-one function, as we discussed earlier. Okay. So how to find the exact value of an inverse function given an expression in the form f inverse of f of x, or f of theta, where f of theta is equal to sine, cosine, or tangent. Evaluate. So if theta is in the restricted domain of f, then f inverse of f of theta is theta. That's what I was trying to say. If not, then find an angle phi within the restricted domain such that f of phi is the same as f of theta. Then f inverse of f of theta is phi. Okay, so this first one, we're doing sine inverse of sine of pi over 3. Now, pi over 3 is within the domain, so we can just go with this being pi over 3. But sine inverse of sine of 2 pi over 3, this is not in the domain, so we would treat this as, it might be helpful. You could just do this. You could say, okay, sine inverse of sine of 2 pi over 3 is the square root of 3 over 2. Sine inverse of the square root of 3 over 2, putting it in the correct domain, is going to be pi over 3. Now, cosine inverse of cosine of 2 pi over 3. Well, cosine of 2 pi over 3 is in the restricted domain for cosine function. So you could just cancel these out and say 2 pi over 3. And then cosine inverse of cosine of negative pi over 3. This is not in the domain. So I would go with this and say, okay, that's cosine inverse of what? What is cosine of negative pi over 3? Well, that's going to be 1/2. And cosine inverse of 1/2 would produce a positive pi over 3. Okay, let's carry on. How to evaluate functions of the form sine inverse of cosine of x. These are kind of fun, actually, and cosine inverse of sine of x. If x is in the interval from 0 to pi, then sine inverse of cosine of x is pi over 2 minus x. If x is not in the interval, then find another angle y that is in the interval, such that cosine of y equals cosine of x, and sine inverse of cosine of x is pi over 2 minus y. So now we go the other direction. If x is in the interval from negative pi over 2 to pi over 2, then cosine inverse of sine of x is going to be pi over 2 minus x. And if x is not in the interval, you find another angle y in the appropriate interval, such that sine of y is sine of x, and cosine inverse of sine of x is pi over 2 minus y. So we're going to evaluate sine inverse of cosine of 13 pi over 6. So if we think about what is 13 pi over 6, so cosine of 13 pi over 6. That's like saying cosine of pi over 6 plus 12 pi over 6, which is cosine of pi over 6 plus 2 pi. Well, that means it just repeats itself with a plus 2 pi. So this is the same thing as saying cosine of pi over 6. So sine, which is going to be the square root of 3 over 2. So sine inverse of the square root of 3 over 2 is going to be pi over 3. So that's how we do direct evaluation. And if you do the method described above, our sine inverse of cosine of 13 pi over 6, I would treat that as sine inverse of cosine of pi over 6. And then that would be pi over 2 minus pi over 6 is pi over 3. Hey, we get the same answer. Coincidence? No, that's how it has to be. Okay. Got a few more here. Find an exact value for sine inverse of cosine of 4/5. Okay. So this means that, is there a typo in this? There is a typo in this. Okay, now I got it correct. So we have cosine, I want to look at this, cosine inverse of 4/5. That produces some angle theta. So this is like saying that cosine of some angle theta is 4/5. So if I were to draw a triangle, this is how I like to address these. And here's my theta. Cosine is the adjacent side over the hypotenuse, so 4 over 5. It's the right triangle. I'm going to call this B. So 4 squared plus B squared is 5 squared. So we have 16 plus B squared is 25. So we subtract the 16. So B squared is 9. So B would be plus or minus square root of 3, but we're going to go with positive, square root of 9, excuse me, so we're going to go with 3. Now, if they told us that there's a certain quadrant that cosine, that the angle was in, we would have to take that into consideration for the sine. So what we have is this theta. We have 4 here, 5 here, and 3 here. Now, when we write sine of cosine inverse of 4/5, as I define it above, that's just saying sine of theta, because I said that cosine inverse of 4/5 is theta. It's just an angle, produces an angle. So if I go back to this triangle that used the theta, sine is going to be the opposite side over the hypotenuse, so that's 3 over 5. That's your answer. I kind of enjoy those myself. Let's try this next one. This video is getting kind of long. So it's along the same lines. So sine of tangent inverse of 7/4. So again, I would say tangent inverse of 7 over 4 is theta. That means the tangent of theta is 7 over 4. So if I make a right triangle, not to scale, the opposite, so tangent's opposite over adjacent. So opposite is 7, adjacent's 4. I say not to scale. Okay. We would use the Pythagorean theorem to find this side C, because sine's going to need it. Sine's going to need to be opposite over hypotenuse. So we do 4 squared plus 7 squared equals C squared. That's going to be 16 plus 49 is C squared. So C squared is 65, or C is the square root of 65. Now your hypotenuse is always going to be a positive value, so 65, not 4. Sorry about that. Always going to be a positive value. So if I wrote sine of tangent inverse of 7/4, that'd be like saying sine of theta, because we just defined this to be theta. Then we can reference this triangle. And that's going to be 7 over the square root of 65. And I don't know, if you want to rationalize the denominator, I don't know if that's really necessary in this case. So 7 root 65 over 65. I think this answer is just sufficient, but they're both equivalent. Now for the most enjoyable one is this, where we're going to find cosine of sine inverse of x over 3. These are kind of cool because we get an answer that has variables in it. Okay, so it's the same type of thing. So I will say sine inverse of x over 3 is equal to theta. That means sine of theta is x over 3. Okay, and so if we have a right triangle, nice thing about having these ratios is, this is my theta, sine is opposite over hypotenuse. So we'll call opposite x hypotenuse 3. And then we can use Pythagorean theorem to find a. So it's going to be a squared plus x squared equals 3 squared. So a squared equals 3 squared is 9. So 9 minus x squared. And a would be the square root of 9 minus x squared. And yes, if we were worried about the quadrant we're in, we'd worry about plus or minus. But we aren't given that to worry about so much. I'm trying to think. It says x could be between -3 and 3. So, yeah, okay, that means -1 to 1. Okay, that's fine. But we don't have the information to worry about that, so we'll just go with the positive. So we have this right triangle of x and 3, and then our a, we'll call that the square root of 9 minus x squared. And we're looking for cosine of that. So what is our cosine of sine inverse of x over 3 is just like saying cosine of theta, which will be adjacent, which is the square root of 9 minus x squared, that's a 9, over 3. And that's it. Okay, we'll stop this video before it gets any longer. Hope that was helpful.